Okay, class, so we missed you, and I know this social distancing is quite the thing, but we'll get through this and this will pass. The key, hey, trust in the Lord. He's in control. I hope that you're praying daily. I hope that you're trusting in Him. He really is the key through all of this. All right, remember, hey, what's the goal right now? A lot of schools are simply reviewing stuff. We're not. We're trying to learn new material. Don't stress over your grades. The key is to learn material. And therefore, anything we learn is bonus. Anything we learn is more than a lot. And so try not to stress over your grades. All of that's going to work out, and just trust that it'll be okay. Do your best, though. You want to do your best, but please don't stress over your grades. Hey, if you were not able to get the quiz turned in time for it to count, don't worry about that, because I have to release this video so that you can use it to get prepared for the test. I understand not everybody's going to be able to get the quiz back to me in time. That's okay. It will not hurt your grade. And so just understand that. Don't stress over your grades. We're going to learn as much as we can in the midst, and I hope that this quiz review will be a help to you. It says 9A, but it's actually the quiz for all of Chapter 9. Okay, let me get into it. First off, reduce and find the excluded values. So remember, when you're looking for excluded values, they're the values of the denominator that make the denominator 0. But first off, we want to find the solution. We want to reduce. So I look to factor the denominator, and I can factor out a common 4. Notice now the 6 is a 2 times 3, and those 2's divide out. So what is the answer to number 1? 3 over x minus 4. Now remember, an x minus 4 cannot equal 0, the value of the variable. Add a positive 4 to get both sides, and you get x cannot equal 4. There's the excluded value. If the x were a 4, the bottom would be 0, and therefore the excluded value is x cannot equal 4. Values of the variable that will make the denominator 0, which is infinity or undefined. Okay, number 2, factor. Got to factor out the common y out of the top. And let's factor the bottom. N and N, 12. I got to get a negative 7 in the middle. Negative 4, negative 3 gives me that negative 7 in the middle. All right, and then notice how these N minus 4's divide out. So what's the answer to number 2? Y over N minus 3. However, remember the excluded values. N minus 3 cannot equal 0, therefore n cannot equal 3. But even though we cross this one off, it still cannot equal 0, and therefore n cannot equal 4. So 3 and 4 are the excluded values. All right, so be able to reduce and be able to figure out excluded values. You don't need to give the excluded values unless we ask for them. All right, it's a concept we're trying to learn so that we can apply really to equations. All right, 3 and 4. So notice I did not ask for excluded values. So it's all about reducing, which is all about factoring, dividing out common factors. All right, I see a common 2 in the top of this one. And trial and error, 2a and a. I got to get to an 11 in the middle. I have 6. Oh, that'll give me a 12. And if that's a negative, that'll give me a negative 12, and a positive 1 gives me that negative 11 in the middle. Okay, so that's it. So notice that's an ugly 6 right there, but that is a 6. So notice that a minus 6 divides into that a minus 6. And that leaves me a 2 over the 2a plus 1, and that's number 3. Number 4, 2 trinomials. We got to factor if we're going to be able to reduce x and x. Positive 3 in the back and a negative 1 gives me that positive 2 in the middle. X and x. Negative 1 gives me that negative 2 in the middle. All right, and again, these x minus 1's divide out. And what's left? X plus 3 over x minus 1. Now, these have excluded values. We're just not asking for them all the time. We just need you to know the concept. Okay, 5 through 7, multiply and or divide can leave your answer in factored form. So it's all about factoring. So the bottom here, trinomial, trial and error, x. Negative 4 in the back gives me a negative 4 in the middle, positive 1 ends up being a negative 3 in the middle. That's correct. Top, factor out the common factors first, take out the common x. That one's done. Bottom, take out the common 2. That one's done. Oops, 2 times the quantity 2x minus 1. That one's done. All right, now notice this 2x minus 2 with that whole 2x minus 2. This x minus 4 with that x minus 4, and that is it. What's left on the top? X. What's left on the bottom? 2 times x plus 1. And by the way, if you put the bottom as a 2x plus 2, that's fine, but you could have left it in factored form. All right, so x over 2 times quantity x plus 1. How about number 6? So again, we're factoring, right? Factoring. Let's factor out a common 2 out of the top left. The bottom is already factored. Now, notice division goes to multiplication, top goes to the bottom, right? So that is now on the bottom, and I'm going to factor the bottom and put it on the top. So x and x. Negative 5, positive 4 in the middle has got to be positive 5, negative 1, and there's the factoring of that. Okay, now let's see if anything divides out. X minus 1, okay. X plus 5, I can do either that one or I could have done that one, right? It doesn't matter, either one. Top and bottom, and that is it. So we have a 2 times an x plus 5 divided by an x plus 3. And again, you can multiply out that top and get 2x plus 10 over x plus 3. All right, so far we've reduced fractions and we've multiplied and divided fractions. All right, here's a complex fraction. So remember, the key is multiplying top and bottom by the LCD over 1. So what is the LCD? You got to look at all the denominators. It's an x times y. So let me show you, here, let me get rid of these circles here. So let me show you what we're going to do. Technically, you got to do the top and bottom by xy over 1, xy over 1. But there's a shortcut, because notice how this has to get distributed. And usually students, when they leave it out front and they cross out the first, here, let me show you. This is what I see a common mistake. They'll do this, and they'll think there's only a y left for the second one, and that's not true. And that's the big mistake here. So let me show you the way I like to write it. I like to go xy over 1, xy over 1, xy to every term. Xy, I'm already distributing. Now I don't make that mistake. X's are gone. X's are gone, Y's are gone. Okay, let's see where we're at. Top, y times y is y squared plus xy. It's an ugly 2 there. Bottom, y times y is y squared minus x times x is x squared. Now, I got to be careful. Does this thing reduce? Well, notice I can factor out a common y out of the top, and I get y plus x. Notice the bottom is a difference of 2 squares. Plus in the middle of one, minus in the middle of the other, square root of the front in the front, square root of the back in the back, and there's the factoring there. And notice now, these y plus x's divide out. All right, so your final answer is y over y minus x. And that's it. You don't need that parentheses on the bottom, by the way, right? Y over y minus x. All right, and that is it for number 7. Complex fractions are complex. Okay, you look at number 8, and again, the key is the LCD. The LCD. So I've got to factor this denominator. So this is an x minus 2, x minus 3. Notice how that gives me the negative 5x in the middle. So now, do you see how your LCD is the x minus 2 times the x minus 3? So I'm going to multiply this side by x minus 2, x minus 3 over 1, and I'm going to do the same thing the other side, x minus 2 times x minus 3 over 1. Notice on the left, the x minus 2's go away. Notice on the right, both go away. Now, what's left on the left? I got to distribute 3 times x, 3x, 3 times negative 3, negative 9, and the only thing left on the right is the x plus 1. Okay, let's add a negative x to both sides. Let's add a positive 9 to both sides, and looks like x equals 5. And there is your solution. Now, you have to be careful and check, can the denominator be a 5? Because we have an equation now. This is why we learned excluded values. Well, x can't be 2, x can't be 2, x can't be 3, so it can be a 5, so we're good. But you know what? You got to check. Okay, next one. Again, I need an LCD. LCD. So I'm looking at my denominators, right? I'm looking at a 3n, a 2, and a 9n. So I hope you understand that that's an 18n. So again, I'm going to distribute to every term the LCD over 1. The LCD over 1. Now, if I did it correctly, all of the denominators will go away. Okay, that goes away, leaves me a 6. That goes away, leaves me a 9n. That goes away, leaving me a 2. All right, front term, 6 times 4, 24, minus 9n times 5, negative 45n. 4 times 2 is 8. All right, I'm going to put the 8 on the left, add a negative 8 to both sides, put the 45n on the right, divide by 45, and there's my answer. N equals 16/45. You got all 2's on the top, and you got 5 and 9 on the bottom, so it does not reduce. 16/45. Just leave it as a fraction. Leave it as a fraction. Okay. I hope you figured out how to come up with the center point, vertical, horizontal asymptotes, domain, and range. If not, this review is for you, and I hope that it'll make sense. Oh, look at that. The graph grid is coming right. I don't know if you see that. I see it right through my webcam. But anyhow, here we go. All right, center point. Remember, the denominator is x minus h, right? Whatever's up there, plus k. So that 7 right there must have come from negative a negative 7. And what is the k? A 3. So negative 7/3 are the coordinates of the center point. Vertical asymptote. Vertical. So that's a vertical line. That's an x equal. And the x coordinate of the center point, quote unquote center point, right? It's an imaginary point. And it's negative 7. Horizontal. Horizontal lines are y equal and the y value of 3. All right, give the domain. Set of all x's such that x is anything except, so x cannot be negative 7. So it's all the real numbers except negative 7. What's the range? The set of all y's such that y cannot be a 3. All the y values except y cannot be 3. All right, let's see if we can apply that now to graph number 11. Let me go a little higher here. Okay, so I want to figure out my center point, and it's 1, 1. Okay, so therefore my vertical asymptote is x equal 1 from that 1, right, from the x value, and my horizontal asymptote is y equals 1 from the y value. So I'm going to put those in. I have a vertical asymptote, and I have a horizontal asymptote. Okay, and the rest is done with an xy chart. Okay, so I'm going to do the right-hand side first. So I'm already at 1, 1. Let's do 2. So here, let me just show it to you so it makes sense. 2 minus 1 plus 1. Okay, so that is going to be a negative 1/2 plus 1. That's going to be a half. So we get the point 2, 1/2. 2, boy, that's bothering me. Let me check, make sure I'm thinking right. 2, oh no, duh. See, bothers me. 2 minus 1 is 1. Negative 1 and 1 is 0. All right, now I feel better. 2, 0. I would have caught it right here, because watch what happens with the 3. Negative 1 over 3 minus 1 plus 1. There's the negative 1/2 plus 1, or 1/2. And I knew they both couldn't be that. And 4, when you do 4, you get negative 1 over 4 minus 1 plus 1. So that's a negative 1/3 plus 1. That's a positive 2/3 right there. And now I know my curve approaches that asymptote and approaches that asymptote. Okay, well, I need this area, right? You notice how they always go diagonal? So I'll do this one in green. XY chart. Now notice my center point is right there, so I'm going to go to 0, right? So I have to do 0, so negative 1 over 0 minus 1 plus 1. Negative 1 over negative 1 is positive 1, so that's a 2. So I get 0, 2. Good. It's exactly where I expected it. Negative 1. Negative 1 over negative 1, negative 1 plus 1. This is negative over negative, or positive 1/2. This is 1/2. Negative 1, 1/2 right there. Do negative 2, negative 1 over negative 2 minus negative 1 plus 1. Okay, this is a negative 3. So negative over negative is positive, so this is 1 1/3. 1 1/3, a little bit lower. Okay, so this one approaches that asymptote, and there's our graph. All right, hope that makes sense to you. If we were asked for the domain and range, the set of all x's such that x cannot equal the 1, what is the y value? Set of all y values such that y cannot equal 1. All right, so that's that middle page. A couple more problems. Find the harmonic mean. All right, you got to know the formula. So the harmonic mean equals n over 1 over x of 1 plus 1 over x of 2 dot dot dot. Okay, so what does that mean? What is n? How many numbers do you have? You have 4 things. All right, so 4 is the top. The bottom, 1 over 2 plus 1 over 6 plus 1 over 8 plus 1 over 12. Okay, I need the LCD. So I have a 2 and 8, a 2, a 6, an 8, and a 12, what, 24? Right? Everything can get to 24. Okay, so I got to multiply the top by 24, and I got to multiply the whole bottom, and I'm going to distribute. 24, 24, 24, 24. Top. 4 times 24, 96. Now watch what happens on the bottom. All these denominators should go away. That's a 12. That's a 4. That's a 3. And that's a 2. So let's add them up. 12, 16, 17, 18, 19, 20, 21. 96 over 21. And that's our answer. 96 over 21. If you turned it into a decimal, it would be approximately 4.6. The harmonic mean. Key is the formula. You're not going to get there without the formula. No way. Okay, work problems. So work problems aren't really exactly the harmonic mean. The key on these is the formula is 1 over. All right, how many people do we have? Sue and Les. So we have 2 people, and that'll equal 1 over both. All right, so Sue can vacuum in 28 minutes. If Les helps, they can vacuum in 20, so that's 20. All right, a little bit of thinking here before we go forward. Sue does it all by herself in 28 minutes. When Les helps, she only saves 8 out of those 28 minutes. Les can't be as quick as Sue, not even close, so we'll find out. And I'm going to put my variable there. Okay, I need LCD. I got to find the LCD. So on this one, LCD, 28 and 20. All right, 28, 4 times 7. 24 times 5, and then an X, and so every column, And so what is it? 28 times 5x. That's 140x. 140x over 1, 140x over 1, 140x over 1. Distribute to every term. All right, let's reduce. 28 goes into 145. Okay, and so we still have the x there. X gets rid of the x's. 20 goes 7. Again, if you do it correctly, all your denominators are gone. All right, so what's the left? 5x plus 140 equals 7x. Let's add a negative 5x to both sides. Let's divide both sides by 2. Looks like x equals 70. Man, Les, you are slow, dude. 70 minutes, or 1 hour and 10 minutes, if you want to put it that way. 1 hour and 10 minutes less is slow. All right. Sue, you are fast. All right, so that's the situation with the banquet room. And so always the work kind of formula, filling up pipes, filling up tanks, those kinds of things. How many people typing, that kind of situation, a work situation, that's the formula. All right, the last few things, inverse and direct proportion. Hey, you've got to have these proportions in your brain. X is inversely. Inversely is the k is on the top and the other variable is on the bottom. Now I need to use what they gave me to find k. So x is 3 and z is 12. Multiply both sides by 12 over 1, k is 36. Now that I know that, I can use that to find the second situation. I could also make a proportion setting k in the middle, but I like doing it this way. You could do it the other way. I'll show you that when I'm done. Okay, now that I know k, new information. Let me do it in black. All right, find x when z is 10. So x equals, what's my k? 36. What's my z? 10. So I have 36 over 10, and I just need to reduce. And so what is that? 18 fifths? 18 fifths. And you say, well, how would you do it with a proportion? Okay, xz equals k. So x1 z1 equals x2 z2. You see, you set it both equal to k in the middle, right? So, that would be that way, and x2 z2 equals k, and you just sub in for your k. Now notice what happens. I'll use the numbers again. So my first x was 3, my z1 was 12, my x2 was 3, and my z2 is what I'm looking for. Oops, why did I say 3? I'm looking right at it. I'm looking for x2, and my z is 10. All right. Divide both sides by 10, and sure enough, you get 36 divided by 10, which again is 18 fifths. So two different ways of doing it. One way is finding k, and then use k in the formula again to get the second situation, or make a proportion. 14b can be done the same way, so I'll show you it as well. All right, r is directly proportional to the square root of d, so k and then the square root of d, or square root of dk, either way. So once again, I got to figure out the value of k if I do it this way. All right, r is 7 and d is 10. So divide both sides by the square root of 10. Now you might say, Mr. Scarfy, you're going to leave a square root in the denominator. We never do that. Well, look, we're not done with the problem. So yeah, I'm going to leave it for now. I'm not going to waste my time. Maybe it'll go away. All right, so how do you then find the second situation? Same formula. And now what did they tell us? Well, we know our k is 7 over the square root of 10. And they told us d is the square root of 20, right? Don't forget it's the square root of d. And now notice, what's the square root of 20 divided by the square root of 10? It's the square root of 2. So see how I didn't have to worry about it? So it's 7 times the square root of 2. You might say again, Mr. Scarfy, how would you do this one with the proportion? Well, again, you got to solve for k, so r equals r over the square root of d equals k. So then the left side would be r over the square root of d, and these are the ones, and the right side would be r over the square root of d, and these would be the 2's. And then you're just going to sub in your value. So again, the left is r1 is 7, d is square root of 10, equals r2 is what we're looking for, over the square root of 20. And again, multiply both sides by the square root of 20 and see how now we're right back to where we were. So two different ways of solving. One is finding k, using k, and the other is proportional method. Just remember, you got to be able to understand and know direct and inverse. You got to know the direct formula, and you got to know the inverse formula. And if you get those mixed up, you're going to be in trouble. So that's the key, knowing direct and inverse. Okay, 15 is a compound problem. So A varies inversely with B, right? But directly with C. Only one K here, not two Ks, just one K. All right, there's our formula. Now again, I can solve for K and I'm going to do this one proportion method, right? So let's see, let's multiply by B and divide by C, right? And therefore, B1 A1 over C1 equals B2 A2 over C2. And what are we looking for? C2. Oh, figures, it's going to be a denominator. Bummer, but that's okay. All right, so what's the first A is, what the first B is 6, the first A is 12, and the first C is 8, and the second B is 5, and the second A is 10 over C sub 2. Remember, you can't solve for a variable in the denominator. You'll get 1 over the answer. Just take it across the equal sign and bring it to the top. Okay, now C2 is in the top. Things in the bottom go to the top. Things in the top go to the bottom. Things in the top go to the bottom. Okay, and now it's just a bunch of reducing, which is going to be a pain, but it reduces, and when you're all done, you get a 50 on the top, and you get a 9 on the bottom. Now again, I could have solved for K and did it the K way. Actually, it would have come out a little bit easier without having to deal with that C2 on the bottom if you would have solved for K. All right, last one. It's been going long, so I got to get going here, and I've got a meeting in a moment, but that's okay. Last one. All right, so you look at this expression, you have to understand functional notation. So our numerator is f of x, which is this, 3x squared plus 4x plus 1. But then it says minus f of 2. So everywhere where the x is, I put in 2. And it's all over 3x plus 10. Okay, that's a 4. 3 times 4 is 12. 3 times 4 times 2 is 8, and 1, so 20, that's a 21. So notice my top now, 3x squared plus 4x, and then 1 minus 21 is a minus 20, all over 3x plus 10. Now, if you wrote that as the answer, you are so close, because I got to see if this thing reduces 3x and x. And you know what? I'm just going to take a shot and put the 10 there. That means the negative 2 has to go there. What do I get? A negative 6 and a positive 10. Sure enough, gives me that 4x. Tricky. And notice how the 3x plus 10s divide out. Final answer, x minus 2. Okay, I know it's a challenging chapter. I understand that. I wish I could have been with you in the classroom each step of the way. I was with you in the videos, but it's different. I understand that. Remember, I have quick review videos online. I have 2 chapter reviews, a new one that I made and the old one that involved a lot of the chapter review questions off the book. We have this video, also quick review videos, and then don't forget www.afterschoolhelp.com from BJU. But that test is Thursday, so I hope you'll get ready. I hope you'll do well. Remember, don't stress over the grades. Everything we learn, you're going to be, whatever you learn is added to that education. It's going to help you toward next year and toward advanced math. So hang in there. Keep working hard. You can only do what you can do, but do your best. Put some time into your math and your English. These are your core subjects and really the key to your education going forward. You can make up a lot of the other stuff. All right, hope you did well. Email me if you got any questions. Be glad to help you. All right, that's it.